Any questions?
Yeah. On the master set, 22,
Yes?
question 14 was a particle traveling at a speed or a velocity in a direction into a magnetic field,
Right?
and it had a certain strength for the magnetic field, and you had to determine what particle it was. Could you do something like that to show how it is then?
Did I give you a chart with various charges and masses?
Yes.
All right, I'm just gonna make numbers up, so it's not gonna match anything on there, but hopefully it gives you enough of an idea. So particle traveling at, say, 3 times 10 to the 6th meters per second, and we'll just call that the I-hat direction. Into a magnetic field of 14, what was the order of magnitude for the speed and the magnetic field?
What do you mean?
Was the speed times 10 to the 6th?
Yeah, the speed was 10 to the negative or positive 6, and then this was the strength was just 0.0024 teslas.
0.0024. All right, so I get 14 millitesla. And presumably, I said which way the particle moved.
Yeah, in the positive y direction on the y-axis.
All right. We'll keep it going that way. All right, so first off, we don't know the charge, we don't know the force, we don't know the radius of curvature there, but we do know a couple of things. One, when it enters a uniform magnetic field, it's going to start to move in a circular orbit. So we got some centripetal motion going on. I know that the force, the magnetic force, acting on the particle is going to be equal to Q V cross V, because that's the formula for a magnetic force on a moving charge. Since the velocity and the magnetic field are perpendicular to each other, the magnitude of this force is just QVB. Technically, that's sine of theta, but theta is 90 degrees, so that's just 1. Sine would be equal to 1. And because it's circular orbit, that's going to be equal to mv squared over r. The speed is not going to change because the force acting on it is perpendicular to the motion, so the speed will stay constant. But we don't know q, we don't know m. So if we solve for q over m, or m over q, whichever way you want to do it, but if I bring m over to the left-hand side and vb over to the right-hand side, one of the v's cancels out, and I'm left with rb. Or if you're feeling saucy, vr. I know v, I know b, actually I do know r. Did I give that?
No, I don't think so. Oh, wait, no. Quarter plane in an arc with a radius of 0.43 meters.
0.43 meters. All right. So let's make r equal to 0.34 meters. So I do know the radius of curvature. Plug and chug, so 3 times 10 to the 6th over 0.34 over 0.014. You work that out, you get something. And so now, I don't know what Q is, I don't know what M is, but I've got a chart there with Q and M for various particles, and I would just do Q over M to see which one comes out with this. Now, whether it's a positive or a negative depends upon, well, positive will curve one way, negatives will curve the other way. I know the force is upwards, so let's pull out our Sten gun here. Bullet comes out the barrel, fingers in the direction of the magnetic field, thumb in the direction of the force. The force is up, in my scenario here, magnetic field is out. So that means the particle is moving that way. However, I know the particle is moving that way. So what does that tell us about the particle?
Curves, it'll like curve and then go back around.
No.
It's negative?
Yes. Because if negative particle going that way is the same in terms of physics as a positive particle going that way. So from this, we know it's a negative charge, so that cuts out half of them, and then based upon Q divided by M, that should narrow it down to one specific one.
So why did you automatically go up?
Why did I go up?
Yeah, the first line for her.
This one?
Yeah.
It's gonna go one direction or the other. I was doing a problem similar to what you had, so I think in that problem it went up. I thought, well, what the heck, let's just put it in the same direction. If I had it curved down, then it would just be the positive version of the particle.
It says curves positive 4. So is positive Z into the board or into the thing?
If I is that way and J is that way, in a right-handed coordinate system, I cross J is K equals K. So I cross J, what's K
So
come out?
positive Z would be out.
Yes.
Because it says it curves in the positive Y and the positive Z. So it's like this way,
And positive Y, so
positive Y and Z.
positive Y and Z, given this coordinate system, given X, Y, and Z, it would have curved out like that.
There.
So presumably my magnetic field in that scenario was pointing in a different direction.
Okay.
Other questions? And now the part of Ibrahim will be played by Ibrahim.